Hello guys, this is AM and welcome to the channel. In this video, we will be looking at how to sort a stack. In one of the last videos, we have seen how to reverse a stack. So we will try to apply the same knowledge or utilize the knowledge we have gained in that to solve this problem. So to sort a stack, the constraints given are we have to use only a stack to solve this problem. So that means we can use more than one stack to solve the problem, and also we have to use the only operations which are performed on the stack, like push, pop, and peek or is empty, etc., which are available generally on any stack. Now let us take an example and see how to sort it. So we have a stack, and let's say we have an integer stack. So we will try to push the integers 1, 4, 2, 5 and 3. So after pushing all the elements, the stack will look like this. So as we have choice to use more than one stack, let's say this is stack A and we have another empty stack at start, and let's call it B. So we'll try to use this stack to somehow sort the elements of stack A. So the main idea in this algorithm is to push the elements into the stack B from stack A until the sorting order is not violated. So let's take an example and see how we can do it. So initially stack B is empty. So we will pop the first element, that is 3, and put it into the stack B. So it is 3. Next we have 5, and we will check if 5 and 3 which is greater. So 5. So the sorting order is not violated, so we will push the 5 into the stack B. So the elements are not there now. So now we have 2 on top of the stack A. So we will try to pop it. So we will check with the top of the stack of B. So it is 2, and the sorting order is violated now. So we have to pop the elements from B and put it onto the A. So right now we have 2 popped off. So we'll have separate reference to 2, but we will pop 5 and put it on A. So again we have to check if the top of the stack and the current element are satisfying the sorting order. So it is 3, and which is also greater. So we have to pop this 3 and put it onto the A, and again check it with the top of the stack. As top of the stack is like the stack is empty, we can push the current element 2 onto the B. So right now the two stacks are at the state where we have started. So we can start this algorithm all over again and perform this again and again to sort the stack, and all the sorting elements will be present in stack B. So a function can be written in such a way that it returns stack B after performing the algorithm. So the complexity of this algorithm is big of n square. So it is not a optimal solution to sort the elements, but if you have only a stack and an elements, it is the best way to sort. So in this video we will also walk through the code and see how the code is written, and there is a surprise element for you in this.
So right now we are in processing environment where we have written code for sorting a stack. A processing environment or processing IDE is generally used for visualizing and creating animations as such. If you want to know more information about processing and what is processing, I'll link in the description below. But right now we will concentrate more on our problem, that is sorting the stack. So let me walk through the code. So for any processing code, there are two main functions, that is setup and draw. The lines in the setup are executed only once in the whole life of the animation. The draw is looped over and over again for forever. So here we have used a class mStack, which is very similar to a normal stack, but it has many other properties such as color, the position on where the canvas is, and the name of the string. I will show you where we will use all this. But moving on, it also has a method display where we display all the elements in a stack on the canvas. So before I move further, let me show you the execution of this program. So this is the stack. The elements in stack A are 1, 4, 2, 5, 3, and 3 is popped and pushed onto B, and 5 is pushed onto B as the sorting order is not violated. Then 2 is pushed, but 5 and 3 are popped and pushed onto A as sorting order is violated. So as you can see, the elements are swapping the positions from A to B, as we have seen in the section 1 of the video on the whiteboard. So right now it is in this last stage where all the elements will be pushed onto B from A. So now all the elements are sorted, and B has all the sorted elements. So that is the execution of the program. Let me walk through the code how I have written this. So I have two stacks A and B. So it takes the name of the stack, and it is the color the stack represents with, and this is the X position on the canvas. Here I'm populating the stack with the elements, so 1, 4, 2, 5 and 3. So after setup, the initialization of the program is done. The draw method loops over and over and again. So this is all that is out of the scope, but moving on, we will display the stack every time the draw method is called. And here we are actually looping over, and if whenever the stack A is empty, that is the case when the algorithm should be stopped. So in that case, we are printing algo done for just development purpose, and no loop method is used to stop the draw loop and break out of it. So we will use this sort method to update the stack every time the draw method is called. So sort method, as we have seen in the demonstration, first we need to hold the topmost element of A, then after that we need to check with B. So first condition we are checking is if it is empty. If it is not empty, then we will check with the top of the B. If top is greater than the temp or the current element we are holding, then we need the sorting order is violated. So we just need to push the topmost element of B to stack A. Until this condition is not violated, we need to do that. So if the stack is empty, or the sorting order, whenever the case where sorting order is not violated, we can just simply push the current element we are holding onto stack B. So M push and M pop are very similar to normal stack. So if you want to see, so M peak, we are just using the st is the stack variable here. So M push and M pop are very similar to that of push and pop of normal stack. As we have walked through the code, I'll again show you the execution, and I hope you will understand even much better this time. I hope you I hope you are liking this format of explaining the problem. If you like, make sure you hit that like button and subscribe to the channel for more videos like this. And I will try to learn more processing environment and how to code in this much better format to get problems like this to you in even to you in a much more better format. So the algorithm is done. So this code will be available on GitHub. The link is in the description below. If you like this and want to learn more about processing, you can fork this and learn more. And if you make this even much better, we'll try to merge the code and let's see how many pull requests we get for this. And I hope you like this format of learning, and I'll get to you in the next video, and I'll see you in the next one.